Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 161, the X and Y axes are the principal axes for the region shown, with I bar x 8 times 10 to the 6 mm to the fourth and I bar y. These are supposedly I bar y, but it is not shown here because in the figure these axes x and y pass through the centroidal axis. So part A, calculate the angle theta for which the product of inertia with respect to the UV axis is maximum, and letter B, determine I sub u, I sub v, and PUV for the angle theta found in part A. So for the solution, we should plot supposedly 8 times 10 to the 6. So I'll just call it 8 comma pxy. And the other point is 2 comma negative pxy. So for PUV to be maximum, pxy should be 0 and PUV should be equal to the radius of the Mohr circle. So if you're going to imagine if the product of inertia with respect to the xy axis is 0, then because x and y are the principal axis of inertia, so the other pair of coordinates should be 0. And therefore, the radius of the Mohr circle should be equal to the maximum product of inertia, which is PUV in this case. So pxy should be 0 and PUV equals r. So after we plot ix comma 0, 8 times 10 to the 6, so we assume that each grid is 1 times 10 to the 6. So that is 8 and the other one is 2 here. And we draw the Mohr circle. So the center is 2 plus 8 divided by 2, so 5 times 10 to the 6. That's it. The radius is 5 minus 2 or 8 minus 5. So 3 times 10 to the 6. So this is the first point plotted. This is x sub c. Pxy should be 0. This is y sub c. And this should be the, from the x-axis, we rotate uh, counterclockwise. That's the positive rotation to get the maximum product of inertia, which is the radius of the Mohr circle, PUV. So that's the u-axis, this is the v-axis, so that the product of inertia is positive. And that's 90 degrees. So therefore, 2 times theta, we have located the u-axis from the centroidal x-axis. We rotate 2 theta counterclockwise in the Mohr circle, and that's 90 degrees. So that's I sub u, this is I sub v, so I sub u equals I sub v equals 5 times 10 to the 6 mm to the fourth. And PUV is the radius, of course. So 2 theta equals 90 degrees. That means theta equals 45 degrees. So that's the answer to the first part. So that's counterclockwise from the x-axis or from the principal x-axis to locate the u-axis. Then the value of I sub u equals I sub v, and it is equal to 5 times 10 to the 6. PUV equals r, PUV max equals r equals 5 times 10 to the 6 minus 2 times 10 to the 6. So it is 3 times 10 to the 6 mm to the fourth. So that's the answer for the maximum product of inertia, PUV. Then I sub u equals I sub v equals 5 times 10 to the 6 mm to the fourth as observed in this figure. So level 162, compute I sub v for the region shown given that I sub u is 140 times 10 to the 6 mm to the fourth. The product of inertia xy is negative 30 times 10 to the 6 mm to the fourth, and theta equals 80 degrees. The u and v axes are principal axes for the region. So if u and v are the principal axes, then I sub u and I sub v should lie on the horizontal axis, the principal axis. So from the x-axis, theta is 18 degrees. In the Mohr circle, we rotate 2 times 18 degrees, 36 degrees counterclockwise. So let's plot ix comma negative 30 and iy comma positive 30. Since u and v axis are principal axis of inertia, this should be on the horizontal axis as shown. So I sub u is, it should be the maximum, 140 times 10 to the 6. So that's an approximate value. I sub u 140 times 10 to the 6. Then we draw the Mohr circle. So that's the u-axis. The v-axis is on this side here. And that's the Mohr circle. I sub u is given. It is equal to IV plus the diameter of the Mohr circle. So that's the diameter. This is also the diameter. This should be the centroidal x-axis because from this axis we rotate 2 theta counterclockwise to locate the u-axis. And theta, 2 theta is 36 degrees. So this is the x-axis, centroidal x-axis. The opposite point on the diameter is the centroidal y-axis. So this is 2 times 18 degrees, 36 degrees. And since product of inertia x sub y is negative 30, which is this, it is equal to negative r sine of 36 degrees in the figure. So that's PUV, negative 30 times 10 to the 6. This is the radius of the Mohr circle. Radius of the Mohr circle. R and R. So this is I sub V. And we can compute that after we solve for R. Because from the figure, I sub V plus 2R equals I sub U. Or I sub U minus 2R equals I sub V. So I sub V is I sub U minus 2R, or I sub V plus 2R equals I sub U. To solve for R, since PUV, PXY is negative 30 times 10 to the 6, and in this right triangle, it is equal to negative R, negative hypotenuse, sine of 36 degrees equals negative 30 times 10 to the 6. So negative R sine of 36 degrees equals negative 30 times 10 to the 6, where 36 degrees is 2 times theta, 2 times 18 degrees. So R is equal to 51.04 times 10 to the 6 mm to the fourth. We then substitute into this formula here to solve for I sub V because I sub U is given. So I sub V is 140 minus 2 times 51.04. Then the answer is coupled with times 10 to the 6. So I sub V is 37.92 times 10 to the 6 mm to the 4th. So that's it for this problem.